Okay, moving on to example 2, solve sine of x plus cosine of x equals 1. Once again, x is between 0 and 2 pi, not including 2 pi. And this one, I can't see an easy way to factor it. There's no squares things in it. The sine of x and cosine of x are in separate terms. There's no common factor going on here. So what I'm probably going to do in a situation like this, the Pythagorean identities on your identity sheet 5 through 13, sine and cosine go together, secant and tangent go together, cosecant and cotangent go together, right? If I'm dealing with those families of things, so sine and cosine, the same things working together there, what I'm going to do is I'm going to separate the two functions. So I'm going to put sine on one side and cosine on the other side. And it doesn't matter which is which. I mean, I put sine over here, put cosine over there. I could just easily left cosine here and put sine over there. It doesn't matter. Just get them separated. So everything on the left-hand side is all about sine. Everything on the right-hand side is all about cosine. And the one's just hanging around. Going to make it more challenging than it has to be, but that's what it's going to do. All right. Then what I'm going to do is I'm going to square both sides. So if I square this side and I square this side, that's just a legal step, right? We're allowed to do that and square both sides. Mm-hmm. Keep in mind, when we did that before, it was with radicals, right? Square root of x equals number. We squared both sides to get x equals, right? We had to verify our solutions. Same thing here. We have to verify solutions. Anytime you do this step here, the answers you get to this problem could make this false. But it will find all the true ones mixed in with the false ones. So what it does is, instead of having infinity possible answers, now there's 10. Okay, these 10 are possible answers, and these 4 actually worked. Or 3 possible answers, these 2 actually worked. So it'll get you all the right answers, but there'll be a couple wrong answers usually thrown in on the mix. So at that point, it's a guess and check problem. So square both sides. This side becomes sine squared of x. The other side, if I square a binomial, I'm going to get the first thing squared, 2 times the product of the two things, and the second thing squared. Within my Pythagorean identities, sine squared is equal to 1 minus cosine squared is 1 minus sine squared. I have the ability to change sine squared into cosine squared or cosine squared into sine squared. I have no way of making cosine anything else though, right? So once I've done that step, and I've established that I can't make cosine go away, all right? I can make this become sine squared, that's sine squared, but I can't make that become sine. I can make that become cosine squared, that already is cosine squared, that's cosine. I can make everything about cosine, right? So that's how I make my decision what I'm going to modify here. So I'm going to change sine squared into 1 minus cosine squared. The rest of the equation is going to stay as it is. And let me just give you a visual of the other thing I was talking about, because I saw some bewildered looks on some people's faces. If I had done the other one, okay, I think this is number 6 here that I did. Sine squared equals 1 minus cosine squared. So if I had done number 7 instead, change cosine squared to 1 minus sine squared, I would have gotten this. Sine squared of x equals 1 minus 2 cosine of x plus 1 minus sine squared of x. If I had changed this to this, sine squared, cosine. Different trig functions, the same problem. That's not going to be easy to solve. Cosine, 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 everything's cosine, that one's going to be easy to solve. So you have decisions to make. I'm going to change one of them, change the one that makes more sense. In this case, that one makes more sense. So at this point, everything's cosine or cosine squared or a number, so I'm going to move everything to one side equal to 0. So I'm going to move the cosine squared over to the right and move the 1 over to the right. So 0 is staying on the left-hand side. Cosine squared, which is positive now, when it moves across, plus cosine squared makes 2 cosine squared. Minus 2 cosine of x, no common fact, no like terms with that. And then when the 1 moves over as a negative one, it cancels the one that's already there. So the ones cancel out. So we just get 2 cosine squared minus 2 cosine equals 0. At this point, common factor of 2 cosine of x. If I take 2 cosine of x out of both objects, we're going to be left with cosine of x minus 1. And that factored form equals 0, which means either 2 cosine of x equals 0, or cosine of x minus 1 equals 0. 2 cosine x equals 0 means cosine of x must equal 0. Divide both sides by 2. Move 1 over, we're going to get cosine of x equals 1. You again, we're looking for answers on the interval from 0 to 2 pi where both of these facts are true. So, for the first fact, this one, cosine equals 0 at pi over 2, and again at 3 pi over 2. Cosine of x equals 1 at 0. Happens again at 2 pi, but we're not including 2 pi. So 0 is the only answer. So altogether, again, I squared both sides. I got those three answers. Those three answers are correct for this equation here. They may not be correct for this equation up here. We've got to go back to the original problem to verify that they're actually correct. Right? And again, I can do that with a calculator if I wish, or I can just use my facts that I memorized, right? Let's try that. So what I've got on the left-hand side is sine of x plus cosine of x, and what's supposed to equal is 1. All right, so I'm going to try this one first, pi over 2. Sine of pi over 2 is? Straight up? Sine's about y? Straight up would be what? 1. Cosine of pi over 2 is 0. 1 plus 0 equals 1 is true, right? So that one works out. Okay, if we try the next one, 3 pi over 2. Sine of 3 pi over 2 is? That's straight down. Negative 1. Cosine of 3 pi over 2? 0. Negative 1 plus 0 does not equal positive 1, right? So we throw that one out. If we try 0, sine of 0 is? That's straight to the right. Cosine of, sine of 0 is 0. Cosine of 0 is? 1. 0 plus 1 is 1 is true, so that one works out. So again, if you employ the strategy of squaring both sides, just know that you have to verify solutions. Negative 1 squared is positive 1. 1 minus 0 is positive 1. Squaring both sides change the negative to a positive. You can't tell that one is still in x form. Once you get to real number form, then you can go ahead and figure it out. So the answers are x equals 0 or pi over 2.